goal. Today we're talking about normal distribution, the last little bit of probability. So just as a heads up, if you don't finish today, we'll finish on Monday, but you guys are going to have a test on all of probability on Friday. So normal distribution, binomial distribution, random variables, and then of course tree diagrams, conditional probability, et cetera, from the very beginning.
Will we review?
And we will review, yes. All right, so make sure you guys get down the goal. Students will be able to find probabilities that are distributed for continuous random variables. Because basically what we were doing with binomial distribution, those were for discrete random variables, okay? Things that, can be counted, like the number of heads that you get when you toss a coin, okay? Those things can be counted. So now we're looking at those particular variables that were continuous, such as time, mass, weight, et cetera, So that's what we're talking about today and how to find those types of probabilities, okay? Did everybody get down their goal? All right, so the normal distribution is the most important distributions for continuous random variables, okay? Again, that's pretty much the only way that we can figure out probabilities when it comes down to things that aren't able to be counted, okay? So if a random variable x has a normal distribution with the mean, mu, and a standard deviation, which symbol is represented kind of with like a circle with the extra tail, it is written in this format, okay? So if you're ever given this format only, you'll know that this is a normal distribution because of the n. Remember, binomial distribution has a b, so that's how you're able to distinguish the two. And of course, the first number will represent your mean, and the second number will represent your standard deviation squared. And if you think about it, we've talked about what that is indirectly. Okay? Huh? What'd you say?
Expected value.
Not expected value. Standard deviation squared is what?
Oh, variance.
It's variance. Because variance is the square root of, or standard deviation is the square root of variance. So if you square standard deviation, you get variance. So technically, this right here is variance. Okay? So don't forget that. My pen's acting a little simple today, so.
Excuse me, Miss Anderson?
Yes. Alright, so mu, mean, is the center point of the distribution, and the standard deviation describes the spread of the distribution, are called parameters of the distribution. Okay, so either one or the other will be given to you, they'll both be given to you. Either way, you can figure out your normal distribution from there. The higher the standard deviation, the wider the normal curve. Okay, and as you look at this next slide, all of these are examples of normal distribution curves. Okay, they represent a bell curve, and no matter what the values of mean or the standard deviation are, the totals underneath the curve will always add up to equal 1. Okay, probability. So if you look here at these curves, I know you can't see it based off yours because your copies are black and white, but if you look up here with the colors, and you see the blue one, okay, it has a particular mean, in this case a mean of 0, and then it has a variance of 0.2. Okay, and if you notice that is a pretty skinny bell curve compared to the one that's in the red, which has a flatter, wider bell curve. The orange, okay, it has an even bigger variance, and so basically, if you can make a conjecture here, the bigger the variance, bigger the curve in the sense of what? In the sense of width, okay? So basically, the wider the curve is. All right, if you notice the green one, okay, its mean is -2, so of course it's going to be shifted over on this horizontal x-axis, and then of course 0.5 has a pretty average halfway spread. Okay. Now the standard normal distribution is where the mean equals 0 and the standard deviation equals 1. The random variable is called z. All right, because it uses its z values to describe the number of standard deviation any value is away from the mean, and that's the notation there. Okay, so if you see z such that, not x, then you know you're talking about a standard normal distribution, which is very different from a regular normal distribution, which we'll talk about in just a second. You use your calculators to calculate the areas underneath the curve of a standard normal distribution for values between a and b. All right, and so what we're going to do is we're going to take a look at an example. So we're talking about distribution. Okay, so the spread of your data, the spread of your probabilities amongst a particular situation. Okay, so given that z such that n 0, 1, the z stands for a standard normal distribution. okay? Your normal distribution where your mean is 0 and your variance is 1. So to find the probability that our random variable here in our standard normal distribution curve is between -1 and +1, we can find by using our calculator. So we pull out our calculator. Alright, so to figure this out, we go to second bars. So press the second button, press our bars button, and we're gonna go down to normal CDF. Okay? So you go to normal CDF and you click enter. So second bars, located right beside the clear button. You go to option 2, normal CDF, and if you look, that light blue above the bars button is distribution. Okay? So if you ever forget, think about, okay, I'm looking for distribution. Here it is. You click enter. Now, if yours shows up like mine, that's cool. If yours doesn't, it might pop up as norm CDF. Okay? No, you gotta go to option 2. Option 2. Okay? And so then, basically what you're gonna type in is you're gonna type in your lower bound, which is -2. Your upper bound, with the commas, I'm sorry, don't forget comma. Y'all remember where comma is? Where is it? Above 7. Comma. And then you're gonna type in your mean, which is 0. And then you're gonna type in a standard deviation, which is 1. Okay? So if yours looks like it just pops up as norm CDF in the blank, you gotta type in all this. So you're gonna type in -2, comma 1, comma 0, comma 1, and close off the parentheses, and it'll give you your probability. If yours looks like mine, I'm gonna type in the same thing. It's just kind of already outlined for me. I got -2. My upper is 1. My mean is 0. My standard deviation is 1. I'm gonna paste it in. So mine's just gonna look like yours at the end. And then when we click enter, we get the probability. And we round to 36 So 0.819. Okay? And as simple as that. So that gives us our probability for the standard normal distribution. Alright? For the next one, we're looking for the probability that the standard normal distribution is less than 1. Now, unlike option A, we don't have a lower and upper bound. We just have an upper bound. So when we go back to the same process, norm, CDF, where do I go? Second bars. And when it pops up, for our lower bound, we basically need a super small number. Because if we're looking at this curve, here's 1, I'm looking for everything that's less than it. So that includes all these super tiny numbers. So my lower bound is going to be a super small number. That number, and honestly you could use like -99.9999, or what I like to do, so this is how I was taught, I like to type -9, second comma, okay? So -9, second comma, and an E should pop up, right? 99. Now this is just the way I was taught. You could do -999, and you probably still get the same answer that I do, okay? But that's just how I was taught. It's just triggered in my mind. Comma, your upper bound, just 1. Your mean, 0. Your standard deviation, 1. You type that in, you get your probability there. So second bars, option 2. So -9, E, 99. Upper was 1, right? This is the same. Paste. Second comma. So same comma, we gotta use the comma to break all this up. Same comma. We click enter. Did you guys get this? Okay. So this is 0.841. Okay. Now what do you think for one that's greater? A really big number? It would be 9E99. Okay? So norm, CDF. My lower bound is a -1.5. My upper is a positive 9E99. My mean, my standard deviation. So your calculator looks like this. And that's what you got? Good stuff. What was it, 933? Alright, do D. It should be 0.5, because think about it. If it's 0 and a normal standard distribution, or standard normal distribution,
To the left, right.
isn't 0 the mean? Okay? And if you notice, all your means, no matter where they are going to cut the bell curve in half. And what's the probability underneath the curve? So it's always going to be 0.5 if it ends up at the mean.
Oh,
So you didn't even do the calculation.
I can smart count.
Okay? Now with E, it's a little different. Absolute value. So the absolute value has to be greater than 0.8. Okay? So, this one's a little bit different because it's absolute value. And we know what does absolute value do to a number? It makes it positive, whether the number you plug in is negative or positive. Okay? So technically, what number the absolute value of z greater than 0.8, z could have been positive 0.8, or negative 0.8, couldn't it? Okay? And so when you have this type of situation and you're trying to figure out the probability, greater, clearly, because if it was less than, you can't have, well, I mean, it could be less than, but it could be less than a negative. You're actually looking for the probability that's in between those two values. So it's not 0.8 lower bound, a super big number for your upper bound. It's actually because the absolute value is bounded in between positive and negative 0.8.
So did you subtract your lower number? Would you subtract that from 1?
So once you find that probability, you would have to subtract that from 1. So find this probability that's in between, doing it the way that we did A, B, and C, more specifically A, because we're bounded in between those. So, did you already do the probability? So probability, lower bound, upper bound, mean, standard deviation, and then that answer, do 1 minus it. And you get 0.4. And that's how you use standard normal distribution. All right? Questions on that? Now, very few real-life variables are distributed like a standard normal distribution. However, you can always transform any normal distribution that's written in this format to a standard normal distribution by using this formula here. Okay, now this is key to know because even though there are ways that you can perform a normal distribution that's not a standard normal distribution, sometimes using this and what we just did is very helpful. Okay, but you still use your graphic calculator to figure out the probability no matter what. Okay. There is a non-calculator way to do it, all right? The formula is a little extensive that I doubt they would even ask you to do, all right? However, if you're doing something else statistics-based for your IA, and you wanted to talk about data or the spread of it, then you definitely want to use that formula, okay? To do it by hand. So, what we're gonna do is we're gonna look at this one, the random variable x, such that n 10 2 squared. Find that probability. Now there's a couple of different things you have to take aware of. What type of distribution is this? not standard normal.
Oh, it's not?
Why is it not standard normal? It doesn't have a z. Instead of in the z place, it's a what? No, it's an x. Because normally it's z, this, n, 0, 1. This is a standard normal distribution. Okay? So this is just a normal distribution. Okay? So what we can do is we can convert it to a standard normal distribution by using that formula here. Okay, z equals x minus mu over theta, because this probability is based off a normal distribution because of the x there. We want that to be a z. So, to do that, all we're going to do is we're going to plug in 9.1 for our x value, subtract the mean, which is what? 10, and then divide it by standard deviation, not 4, 2. Because remember, this is in the format of our standard deviation squared. So that 2 is just that standard deviation. So what's 9.1 minus 10 divided by 2? What? 24 pi. Negative 0.45? Okay, I thought you were saying 4 pi. Okay. So we're converting to a standard normal distribution. So it's turning, so that x is going to turn to a z, that 9.1 is going to turn to a negative 0.45. And then to change this one, we're going to do the same thing except plug in 10.3 for x. And what do you get? And both of these are ending, right? Awesome. So this will be the setup for a normal distribution. This here is the setup for a standard normal distribution. And you guys can find this probability. We just practiced that. Yes?
Where did the 10.3
From what they want us to find the probability. You're welcome. Are the mean and standard deviation the same as 10 and 2? No, because once we convert it to a standard normal distribution, our mean becomes 0 and our standard deviation becomes 1.
Is that standard?
And that is standard for standard normal distribution. Yeah.
They will never be.
Not for a standard normal distribution, it will always be 0 and 1. When it's a regular normal distribution, they could be anything. What you guys get?
0, 1, 2, 3, 3.
0, 2, 3, 3?
No, point.
2, 3. Awesome. So yes, there is a way to do it without having to convert, okay? But as I was explaining earlier, sometimes they might ask you to do it as a standard normal distribution instead of just a regular distribution, okay? And the other method is basically take that same problem. I believe it was 9.1 less than x less than 10.3, right?
Yes.
Where our mean was 10 and our standard deviation was 2 because it was being squared. So to do the other method is what you see, okay? You still go to norm, CEF, by pressing second bars. In this case, you want to type in your lower bound, your upper bound, your original mean, which was 10, and your standard deviation of 2. And you'll see that when you do that, because I want everyone to do that.
They always give you the proper
Yeah. So we'll look at all the problems. And you'll notice that it's actually the same thing. There's only one issue with the normal distribution. If it's not one of these where it's bounded in between two numbers, no matter what, you always have to find the area that's to the left of that particular value. So say it was one of those types of problems where it says that x is greater than 5.2, okay? It would always have to be that probability that is less than that value, okay? You would find this probability to get this answer. That's the one condition about using a normal distribution.
So you do one minus that?
So you have to do 1 minus this, because that's what the calculator does, okay? It always finds the probability that's to the left. So if you're looking for something that's greater than a value, you have to do 1 minus it, okay? That's the one condition about using a normal distribution curve. Now with the standard normal distribution curve, you don't have to worry about that. You just have to convert. So it's one or the other. Questions on that? Let's look at an example. After we look at this. Here's a normal distribution curve, okay? It is broken down roughly into 3 areas, okay? Of course, you have your mean that splits this bell curve symmetrically in half, and everything is symmetric on both, basically on either side, okay? You have your mean, and then you have one standard deviation that you see in the orange, okay? That, from whatever that value is to the other value, that makes up 68%, about 68% of your probability, okay? So out of the whole 1, whatever those 2 numbers are within one standard deviation is 68%, okay? What you see with the orange plus the green, so from here to here, that makes up 95%, okay? And that's 2 standard deviations away. So by that, and then you have from here to here, you have 1 standard deviation, 2 standard deviations. What would the next one be? 3 standard deviations away. Alright? And sometimes they may ask you to draw these different types of probabilities. That makes up 99.7% of your probability.
Is this a general?
This is yeah, and it's always broken down like this. They could ask you a question like this in a non-calculator section, and you would need to know these probabilities. All right. Also realize that because it's a bell curve, and that means cuts it in half, that means that from here to here, so from that 1 standard deviation to the mean, what's that percentage? 34. Because it's half of that 68. Okay, that mean cuts that percentage in half. So it's 34 between 1 standard deviation and the mean, and then it's 34 on the other side. Okay? From 2 standard deviations to the mean, how much is that? It would be 47.5% on both sides. From 3 standard deviations to the mean, what? So if you can just remember these probabilities for 1 standard deviation, 2, and 3, so the orange, the green, and then the red, then and also that the mean cuts it in half, you will also be able to figure these out. This is important to know for those questions that are non-calculator, okay? So they'll basically give you an example like that. Let's see if it explains it. Yeah, you'll see the next example. All right. So, like I said, it's good to know the breakdown because they can ask you without a calculator. So here's an example of that. It said let x be normally distributed with a mean of 75 and a standard deviation of 5. Okay? So if it's normally distributed, they could write it like this out in words, or they could show you in the symbols, which will look like this. Or they could even say 25. You just have to know that you have to take the square root of it. Okay? Then it says to draw a normal distribution curve to represent this information, okay? Well, our normal distribution curve always has a horizontal axis, okay? That's where the mean is located, and that's where all the other numbers that are associated with it. It is a bell curve that is symmetric, so you do your best to draw your best bell curve. And it is, I believe the word is asymptotic to that horizontal axis, so it should never cross or touch. Straight in the middle, you have your mean, which in this particular problem is 75. From there, you will want to draw your standard distributions, okay? And if you look at the other graph from the previous slide, to get this one standard deviation, you have to take the mean and add one standard deviation. So that's 5. So what would this value be? 80. To get the one on the other side, you would subtract it to get 70. And that would be one standard deviation. You then would need to do 2 standard deviations. Okay? So that'd be 75 plus 2 standard deviations to get 85. Or you can continue to add 5 to the previous standard deviation. Or subtract 5 from the previous standard deviation, or subtract 2 standard deviations, which would be what? 65. So remember, from red to red, that makes up how much of a percentage? 68. 2 standard deviations make up 95, and then the last one is 99.7, which will be the values of 90 and 60. So that would be how you would draw a normal distribution curve. Any questions about that? And then of course they can ask you any types of questions related off that, such as given that P, the normal, the random variable is less than 65, equals the probability that X is greater than A, you need to find the value of A. Alright? So to do that, first off, you need to figure out, okay, what is the probability that it's less than 65? Well, less than 65, this is basically what they're asking for. What's that probability? What's that area underneath the curve? And 65 was located on which standard distribution? Or standard deviation? The second one. Okay? And how much did the second standard deviation make up? 95%. Alright? But that was just in between here and here. We got these 47.5 was from one standard, 2 standards to the mean, right? And then what about from the mean all the way to the end? How much is that? 50%. So if from here to here it's 47.5, and from here to here it's 50, how do you figure out this probability right here? Add those two and then subtract it to get what? And this is without a calculator. So what's 47.5 plus 50? So if I subtract that from 1, 2.5%. So that's your probability, a percentage. And you have to figure out what other value of A has the same type of percentage. So they could just ask you just this part without this. They could just say, what is that probability? You would need to know those breakdowns. Okay? Because 85 has the same probability on the other side, because it was asking you what is the value of A that this probability equals 2.5. They could also ask you something like this. And it's actually found the probability that is greater than A. Do we know A?
Yeah.
Is it the same A? You 100%? No? Why aren't you 100%? 0.954. A is 85. 0.954. I told you those were values, approximations, right? It's about 68.2, 95.4, and 99.7. Those are three significant figures. If you want to add that into those numbers. Okay? So yes, it is this probability. So if A is 85, find the probability that X is greater than A. What's that answer? Say again. Not 0.05, 2.5. Because that's what we just found out up here, right?
Just on the other side.
Because remember, to find the greater than, you either want to find all this probability, which we technically found the other way, and then just subtract
Because they're equal.
because they're equal. Yes, they're all symmetric. Take a look at this. Eggs laid by a chicken are known to have the mass normally distributed with a mean of 55 grams and a standard deviation of 2.5 grams. What is the probability that the egg weighs more than 59 grams? How would I set that up? Using proper notation. How would I set this up? Find the probability that the egg weighs more than 59 grams. P. Because it might be helpful when it comes down time to figure this out, right? X, because it's a normal distribution, not standard normal, so we know it's going to be set up as X, such that N, what goes here? It's the mean, and then standard deviation squared. So I'm looking for the probability that an egg weighs more than 59 grams. So that would be P. X is greater than 59, right? You've seen this notation. We practiced with this, right? Where do I go to figure out this probability? To your calculator. Because does this fall within 1, 2, or 3 standard deviations? Like, does it fall on one of those bars? If the mean is 55, what's one standard deviation to the right? 57.5. What's 2 standard deviations? So does 59 fall on 1 or 2 standard deviations? Like on the bar? If it doesn't fall on the bar, then you can't do this without a calculator. It would have to be. But if it was 57.5, 60, or any of the other ones symmetrical on the other side, you would have to use a calculator. All right?
What if it says like 65? Like if the next one after 60.5?
It doesn't go to the 4 standard deviations. Oh, it's not. This class doesn't. Find this out. Find this probability. And then using a similar process, find B and C. The inverse normal distribution. This is when you need to find a value in the data that has a given cumulative probability. So this is the opposite. Instead of them giving you the actual, find the probability that it is 53 grams, now they're actually giving you the probability and they want you to find the 53. Okay? So to do this, we use something that's called inverse normal. Oh, I have an example. So a company fills cartons of juice to a nominal value of 150 milliliters. 5% of the cartons are rejected for containing too little juice. The owner of the company may wish to find a cut-off point for the minimum volume of a carton, okay? And so basically it would be your job to figure out that minimum value, that X value, given the probability that if it has 5% or if it has a certain value or percentage that's less than what they want. So here's an example. You're given the probability. That's a normal distribution with a mean of 15, standard deviation of 3. You want to determine what that X value is, that when you look at your normal distribution curve, 75%, okay? Whatever this value is, this is what you're looking for. That the percentage is less than that is 75, okay? So to find that value, you go back to second bars, and you go to option 3, which says inverse norm, right? Is that option 3?
Yeah.
Okay. And I don't think it says all the way inverse, I think it says I am the norm. Go back to second bars, go down to option 3, okay? What you wanna type in, if yours pops up, you wanna type in your probability as a decimal. Then you wanna type in your mean, and then your standard deviation. Okay, so our probability was 0.75. Our mean is 15. Standard deviation is
You put 3 squared
3.
or just 3?
just 3. Because remember, the standard deviation squared is variance. So your screen should look like this. And when you click enter, you will find that X value in 17. The only time you would go up is if this was like a 0.99. So that X value is 17. Or 17.0. Okay? So, same area. It's just use inverse norm whenever you're looking for an actual X value. And they give you the probability. Okay? Let's look at the next one. It's actually the juice one. Cartons of juice are such that their volumes are normally distributed with a mean of 150 and a standard deviation of 5. 5% of the cartons are rejected for containing too little juice. Find the minimum volume to the nearest milliliter that the cartons must contain if it is to be accepted. Okay?
Wait, there's 2 of these.
Huh? What?
I thought we had 2.
Okay? So your mean is 150, and you're trying to find the value where 5% of the cartons are rejected, okay, for having too little juice. So, you're going to do the inverse norm, and what's your probability? 0.05, okay? So we're looking for some value, 0.05. That's rejected. So in norm, you still type in the mean, which is 150, and the standard deviation, which is 5. And you come out to get 141, 142, because you're rounding to the nearest milliliter. So, if the cartons have less than 142 milliliters of juice, it gets rejected. That's that value.
You need to write it as a.
Like as a sentence.
No, like X less than.
This is actually fine. Someone else, yes? Okay. Do we have one more?
And you can identify if they say, like, they give you the probability and ask for and that.
Well, they can say minimum or maximum volume. The thing is that it basically tells you in the very beginning, the cartons of juice are such that their volumes are normally distributed. Okay, so that random variable X represents your volume of juice. Okay, that's being normally distributed with a mean of 150 and a standard deviation of 5. So you'll know that, hey, I'm looking for that X value since they're asking me to find a minimum volume. Okay? However, they may ask you to find the mean or the standard deviation or both instead. Such as in this example, sacks of potatoes with a mean weight of 5 kilograms are packed by an automatic loader. In a test, it was found that 10% of the bags were over 5.2 kilograms. It uses information to find the standard deviation of the process. So if we look at it,
So 10%.
what's our mean?
5.
5. And they're asking us to find our standard deviation. So we have a lot of information here. The first little bit is what?
10% over 5.2.
10% of the bags are over 5.2. So how would I represent that? Okay, that's good to know.
Can't you,
Can't you? Possibly, huh? So that you have the 0 and the 1. Yes. You would need to use the standardized or the standard normal distribution formula to help you out here. That's what I went over at the very beginning. Situations like this, okay? So we know that Z equals what that formula? What's that formula? X, which is 5.2, minus the mean, which is 5 over what's that? Sigma. That's lowercase sigma. That's what it is. Okay. And so that basically equals what's that? 2.8. 0.2. Wow. Okay. So that's what Z equals. We can use that now to figure a few things out. So we're going to change this to a standard normal distribution. Okay, so I'm going to replace X with Z. And now, instead of writing 5.2, I'm going to write what I have over there. 0.2 over sigma equals 0.1. All right? And so now that I have that, I can use the inverse norm to find my standard deviation. So, inverse norm what comes with inverse norm? What comes next? The probability. 0.1. Uh-huh. 0 and 1. Mean is 0. Standard deviation is 1. What do you get? Okay. About 1 point. You said negative. Okay. All right, and our mean was something. 5. Okay. So negative 1.28 is here. That probability is that 0.1. Is that to the left of this line or to the right of this line? Which part? To the left of this line. Okay? And so we're trying to figure out that probability that's actually going to be greater. We don't want the negative version. We want the positive version. Because the positive version is going to give us that probability of it being greater than 5.2. So we'll take the absolute value of this to get 1.8, and that is what Z is. That's not what our standard deviation is, that's what Z is.
Wait, 1.8?
Mm-hmm.
1.28.
I'm sorry, 1.28. I wrote that just a second. I'm sorry. So the last thing you have to do is plug it in for Z and solve for your standard deviation. Which is 6 point.
Wait, no,
0.156. There you go. Because you have to multiply both sides by theta, and then you'll end up dividing 0.2 by 1. 1.28.
I did it backwards.
So 0.15. Alright,
Good job, yeah.
so let's recap. Let's recap. We knew the probability, we knew x, but since we were looking, and we knew the mean, but since we were looking for our standard deviation, we had to convert to a standard normal distribution to temporarily basically say, okay, we already have our mean, we already have our standard deviation to help us figure out our z. Because then from there, we can go back to figure out our standard deviation for a normal distribution. Alright?
So why did you set, the z equals,
So basically, this was like our formula here that we need to use to look at. We're gonna look at another one. Look at the next one. It says a manufacturer does not know the mean of, I'm going around time.
Wait, oh yeah, I'm confused. Why did we do absolute value?
Because we wanted the one that was
and they're basically.
the greater value. So we wanted the absolute value, we wanted the positive one over here. This could have also been figured out by instead of using 0.1, we could have used 0.9.
Oh, yeah. Is
Okay.
that because it's,
Probability.
Greater.
I wonder.
So that 0.1 was the smaller value, but we were looking for the greater value. So we could have used 0.9 instead,
Could you have
and that would have
done,
given us the positive version.
could you have done, a normal CDF?
No, you wouldn't have been able to use it, because you didn't have your standard deviation.
so you only use the positive.
Alright, I'm gonna put the last one up. Your homework is is basically, the last one. The other problems are IB word problems, okay, on, normal distribution, so I want you guys to do those for your homework, so it's attached to your notes, okay? I'll put up the video and this last one, so you guys can have it as a reference to look at over the weekend. Have a good one. So to finish off this problem, this last one, so you guys can have it.
Students involved with the 90-10 dis-
So to finish up the problem, so you guys can have just another reference for when you guys are doing your notes. It says a manufacturer does not know the mean and standard deviation of the diameter of a ball bearing she is producing. However, a sieving system rejects all ball bearings larger than 2.4 centimeters and those under 1.8 centimeters in diameter. A sieving system is nothing but like a strainer. So this one's for balls. It is found that 8% of the ball bearings are rejected as too small and 5.5% as too big. What is the mean and standard deviation of the ball bearings produced? Okay, so basically we know that these ball bearings are random variable are normally distributed. Okay, the only thing is we don't know our mean or our standard deviation. Okay, however, we do know that the probability that the balls have a diameter that are less than 1.8 is 8%, so that's 0.08. And we also know that the probability that, I don't know why I'm going to D, is greater than 2.4 is 5.5%. So that is not 0.55, but 0.55. Okay? We know those probabilities. Okay? So what we're going to do is we're going to go ahead and standardize these values so then that way we can maybe set up an equation of some kind to figure out our mean and standard deviation. So we know for these two situations we're going to have two different ones. We're going to have 1.8 minus the mean over standard deviation, and we're going to have 2.4 minus the mean over the standard deviation, because we basically have two values here that basically is being rejected. The probability is 1.8, it's less than that is rejected, and then 2.4, if it's bigger than that, it's rejected, okay? And those are their respective probabilities. So once we get our expression, this is what we have. We have the probability that z is less than this, and then we also have equals 0.08, and then for this one, we want to do the probability that's to the left of this one, okay? okay? So we have to basically switch it, and then this is what we have there. The reason why we have to switch is because when we're doing standard normal, we want the probability that's to the left of that x value. So that's why we do the opposite. We do not greater than, but we do less than. And then on top of that, it equals our probability that's less than, that's to the left of that x value, which is 0.945, okay? And so we're gonna do our inverse norm with these respective probabilities and a mean of 0 and a standard deviation of 1 to find our respective z values, okay? So for this one, once we do inverse norm, second bars, option 3, 0.08, 0 and 1. We get a negative 1.41. Or 0, 8 and some change. We're going to do the same thing with the other, but remember we're using the probability that's to the left, which is 1.60 or 1.598 and some change. And since those are respective z's, we're going to actually set them equal to those equations that we have, because those are the values of z, okay? So basically what we have is we have a negative 1 point, if I use the whole decimal, and I also have all right? And what I can do is I can set up a system and solve this. I'm just going to go ahead and multiply this value over. Basically, I have a system, okay? If I solve for the mean, this is what I'll end up having. I'm going to plug that value in over here. I'm gonna go ahead and add over my standard deviations. This becomes 0.6 over here, and when I add that standard deviation, okay, give me a minute. Positive. That's positive. Since it's positive, I'm going to go ahead and change that to a positive. This is what I have there. And so what I'm going to end up doing is going to end up dividing 0.6 by that answer to get my standard deviation of 2. Okay? So I divide that decimal to get theta by itself, and theta is about 0.2. Then I'm going to go and I'm going to plug that into either one of these. And I know it might be a little much to try to keep these long decimals in there. So if you end up rounding 3 significant figures, I mean, hey, I don't blame you. When I plug it in, I get a mean of 2.08. And I know a lot of this is really challenging, it's kind of hard to grasp, but the more you practice, like such as with your homework, the easier that'll become, okay? So just make sure you bring your questions for Monday, and make sure you start studying.